In the last 10 minutes, an astonishing amount of information has been created by our species. Every 60 seconds, millions of messages crisscross the globe. This cascade of data is more than all the information generated in the entire history of humankind before the year 2000. It is a digital flood of immense proportions. This data does not simply vanish. It is the lifeblood of a new technological ecosystem, a force that is reshaping our world. It feeds the minds of machines. It guides the hands of surgeons. It transforms the very fabric of our economies and our daily existence. Artificial intelligence, or AI, can be understood as the attempt to create a form of intelligence in machines. It is not the same as human consciousness. It is a tool designed to perceive its environment and to take actions to achieve a specific goal. A key part of AI is machine learning, the process by which these machines learn from data, much like we learn from experience. They identify patterns, make predictions, and improve their performance over time, without being explicitly programmed for every single task. A newer form, generative AI, can even create entirely new things. Text, images, music. A familiar example, voice assistants on our phones. When we ask a question, the device uses AI to understand the patterns in our speech. It searches vast databases to find the most relevant answer and speaks it back to us. It learns from every interaction, becoming slightly better at understanding our accents, our phrasing, our intent. Asking for the weather is a small, everyday miracle of machine learning, a glimpse into the power of these digital minds to process and respond to the world. In industry, AI is a powerful force for change. It lets businesses sift data to spot trends and predict demand, manage stock, and reduce waste. In finance, AI monitors transactions for fraud, protecting banks and customers. They perform these tasks at a scale and speed impossible for a human, becoming an indispensable partner in the modern economy. Quantum computing is a truly different way of thinking about calculation. Our current computers, from laptops to supercomputers, store information as bits, a series of ones and zeros. It is a binary black or white world. Quantum computers, however, operate in the strange and wonderful realm of quantum mechanics. They use qubits, which can exist as a 1, a 0, or both at the same time. This ability, known as superposition, allows them to explore a vast number of possibilities simultaneously. They are not simply faster versions of the computers we know, they are a new species of machine designed to solve problems that are currently unsolvable. Consider discovering a new medicine. There are countless molecules, but testing each in a lab would take centuries. A quantum computer could simulate many interactions at the same time, exploring the landscape of chemistry in a fraction of the time. This could accelerate the search for new drugs to combat illnesses like cancer, Alzheimer's, offering a powerful new tool in the fight for human health and longevity. For industry, the potential is revolutionary, designing new materials, stronger, lighter alloys for aircraft, more efficient catalysts for fertilizers. They could optimize incredibly complex logistical problems, managing global shipping routes, and the flow of energy through a national power grid, saving immense amounts of fuel and time. The promise of quantum computing is not just about doing things faster. It is about doing things once thought impossible, unlocking new frontiers. While a quantum computer is not yet in our homes, its impact may be felt sooner than we think. The economy could see a boost as companies harness this power, creating new industries and expertise. For our daily lives, the indirect benefits could be immense. New medicines, hyper-efficient batteries, safer, more sustainable materials could all stem from this quantum leap in computation. It is a technology that, while hidden from view, has the potential to improve the very foundations of our world. The Internet of Things, or IoT, describes a vast and growing network of physical objects. These are not just computers and phones, but everyday items embedded with sensors, software, other technologies. From a simple thermostat to a complex factory machine, These devices are all connected to the internet. They continuously collect and share data about the world around them. This creates a living, breathing digital map of our physical environment. In this world, inanimate objects gain a voice, constantly whispering data to each other and to the wider network. Together they form a global nervous system of connected devices. A simple example, the smart thermostat. It does more than regulate temperature. It learns daily rhythms, knows when people are home or away, lowers energy when empty, then restores comfort before return, saving energy with no loss of comfort. In industry, factories are filled with sensors streaming real-time data. If a machine vibrates abnormally, the system flags it for maintenance before it breaks, saving time, money, and improving safety. The impacts are profound. For companies, IoT reduces waste, lowers costs, improves worker safety, building a more resilient economy. For people, IoT brings convenience. Smartwatches monitor our health. Smart refrigerators tell us when we're low on milk. Connected cars warn us of traffic ahead. Step by step, this network of talking objects is making life safer, healthier, and simpler. Extended reality, or XR, is a term that encompasses a spectrum of immersive technologies that are changing how we interact with digital information. At one end is virtual reality, or VR. This technology completely immerses a user in a fully artificial environment, blocking out the physical world. In the middle is augmented reality, or AR, overlays digital information, text, graphics, animations, onto our view of the real world, often through a smartphone. At the far end is mixed reality, or MR, blending the real and digital worlds so virtual objects can interact with the physical environment. Imagine a history student exploring ancient Rome. She puts on a VR headset. Suddenly she is standing in the Roman Forum, able to walk among towering columns and hear the simulated city. She can look around in any direction, experiencing scale and grandeur. This immersive experience creates a deeper, more memorable connection than traditional methods. XR is a powerful tool. Pilots practice emergencies safely. Surgeons overlay organ models with precision. Car designers iterate on full-scale virtual models before prototyping. It is creating new markets for entertainment, education, social interaction. In commerce, AR lets us preview furniture at home, changing how we shop. XR can revolutionize how we work, learn, and play. Virtual meetings that feel co-present and expert step-by-step visual instructions for repairs. XR is a bridge between the digital and physical worlds, and we have only just begun to cross it. Really. Cloud and edge computing are two sides of the same coin, working together to manage the immense flow of data. Cloud computing uses a network of remote servers hosted on the internet to store, manage, and process data, accessible from anywhere. Edge computing brings computation closer to the source of data, processing information on or near the device rather than a distant server. On a video call, streams route through powerful cloud servers, ensuring smooth, stable connections. A self-driving car cannot wait for round trips to the cloud. It uses edge computing to react in fractions of a second. The cloud gives access to massive compute without building data centers, democratizing technology so startups can scale and compete. Edge enables real-time control in factories and plants, improving efficiency and safety. This lowers barriers to entry and shifts costs to pay only for what you use. For our daily lives, cloud and edge are the invisible infrastructure powering so much we do. When we stream or back up photos, we use the cloud. As devices get smarter, from cars to home assistants, edge makes them responsive in the moment. It really is the backbone of so much we take for granted. Biotechnology uses living organisms and biological systems to create new products and technologies. It is a discipline as old as the brewing of beer, the baking of bread. Modern biotechnology, especially genetic engineering, has taken this to an entirely new level. Genetic engineering allows scientists to directly read, edit, write the genetic code, the DNA, the blueprint for life. By precisely altering this code, it is possible to develop new treatments, create more resilient crops, produce sustainable biofuels. Today, through genetic testing, doctors can analyze a patient's unique DNA, revealing likely drug response. For cancer, they can choose a chemotherapy most effective and least harmful, shifting care from treating disease to treating the individual. Pharmaceutical companies use genetic engineering to create a new generation of drugs, including therapies that target root genetic causes. In agriculture, scientists develop crops naturally resistant to pests, drought, helping secure the food supply. This enables new sustainable materials and chemicals, reducing reliance on fossil fuels. The impact is immense. Growth of new industries and skilled jobs in research, medicine, agriculture. By speeding drug discovery and making farming more efficient, it can lower costs and improve well-being globally. It promises more effective medicines, a more stable food supply, new sustainable products. It shows our ability to partner with nature to solve major challenges. Well, it's really changing how we live. Robotics designs, builds, operates robots. Machines programmed to carry out actions automatically. Automation uses technology to perform tasks previously done by humans. Once tied to repetitive car assembly, robots are now more sophisticated, more mobile, more intelligent. They are moving into our hospitals, warehouses, shops, homes, taking on an expanding range of duties. A surgeon can sit at a console with a magnified 3D image, guiding robotic arms to perform delicate procedures with steadiness and precision beyond the human hand. Smaller incisions, less blood loss, faster recovery. The robot does not replace the surgeon, it extends the surgeon's skill. Fleets of autonomous robots locate, lift, transport goods, working tirelessly, dramatically increasing logistics efficiency. In agriculture, automated tractors plow and plant with accuracy, while drones monitor crop health. Robots handle dangerous environments, freeing humans for safer, more creative and strategic roles. Automation lowers production costs and boosts competitiveness. While it changes the job landscape, it creates demand for people who design, maintain, and manage these systems. In daily life, from self-checkout to robot vacuums, automatons are becoming our partners, quietly taking on the mundane and leaving us more time for the human ones. They're becoming part of everyday life. Blockchain is a fundamentally new way of recording and verifying information. At its heart, it is a digital ledger, like a bookkeeper's log. Unlike a ledger kept by one organization, a blockchain is distributed, copies held by many computers. New transactions are cryptographically linked, creating a chain that is incredibly secure. Once a block is added, altering it without network consensus is practically impossible, creating a shared, permanent record of truth. From a farm in South America to a European cafe, every step can be recorded. A consumer scans a code and sees the verified journey, transparency that builds trust and ethics. In supply chains, finance, and legal agreements where trust is hard, blockchain creates a single shared source of truth that no single party controls. This can reduce fraud, eliminate costly intermediaries, and speed transactions. Banks can settle payments in minutes. Shippers track goods with confidence. The potential is just beginning. Streamlining real estate, enabling fair royalties, building secure digital identity, even verifiable and transparent voting systems. While it is a complex technology, its core promise is simple: to let us share information and transact with greater security and trust than ever before. Well, that's the hope anyway.